Alright gang, Miss Gregory making an advanced Chapter 3 integer test review. Remember, you need your notes, notebook paper, pencil, pen, whatever else you need, your book. But you need to write this down on your own notebook paper and turn it in on the test day. Thanks. Alright, starting with questions that could come from lesson 3.1, dealing with how to write integers in certain situations and finding absolute value. You will be asked to evaluate using absolute value bars. Remember, absolute value is the distance from 0, so it is not negative. Okay, continue to write the examples that you see coming up on the screen, and I'll talk about them in just a second. Alright, so notice the absolute value of -7, counting how far is that number from 0. It's 7 places from 0. Positive answer. Even if they throw in operations with absolute value bars, not a problem. You just need to work out an extra step instead of trying to solve it in your head. So find the absolute value of -3, which is 3. Absolute value of 4. Now the problem becomes, what is 3 plus 4? That's easy, 7. Okay, same thing if it's subtraction. Absolute value of -5 is 5. Absolute value of -2 is 2. Now your problem is, what's 5 minus 2, which is obviously 3. Don't make these problems hard. These are easy points to get on your test. Alright, some other examples of just some words that you may run across that represent things being a negative. A loss, like a loss in yards for football. Withdraw, like you withdraw money from your checking account. Or when you're talking about temperatures below 0 or elevations being below sea level. Some things that represent positive situations with integers would be a gain of 5 yards in football, or you deposit money into your checking account, or you have temperatures above 0, or you have elevations that are above sea level. Okay, make sure you pause if you need to write this down, and then move on when you're ready to the next slide. These are examples from lesson 3.2, adding integers. And when you add, you use LADs. Like signs add and different signs subtract. So here are a few examples I'd like for you to write down and practice. Remember that you are to keep the sign of the one with the greater absolute value. That's how you know if your answer is going to be a positive or a negative. Now, I could give just one step. I could give multiple step, mixed up operations. You guys know your PEMDAS and how to follow that through. So the first example, 13 plus -7. Since they have different signs, the problem is 13 minus 7. Since 13 has the greater absolute value, you would have a positive answer, 6. Remember, when you add two negatives, your answer also has to be negative. Like signs, you can add. So -11 would be the answer for -5 plus -6. Now here's a problem where there's more than one operation following your PEMDAS. -2 plus 3, answer is 1. 1 plus -1, that makes a 0 pair. Okay, you can always do extra practice problems from the book or self-check quizzes, whatever you need to practice. Alright, some examples from lesson 3.3 on subtracting integers. This is where the keep, change comes into play. When you subtract, you need to keep, change. Then it's an addition problem, and you go back to solving with LADs. Like signs add, different signs subtract. Remember, only use keep, change with subtraction. And remember, keep, change really means you're adding the opposite. So here's a quick example here. You can see in red I went over the problem and did the keep, change, change. I kept the negative 17, I changed subtraction to addition, and I changed the negative 6 to a positive 6. Problem becomes 17 minus 6. Negative 17 has the greater absolute value, so I need to keep a sign of negative 11 with my answer. Another example again with more than one operation. Make sure you write both of these examples down. Make sure you understand them. Negative 30 plus negative 5 plus negative 5. Okay, they're all negative, so you can add everything up, whichever order is best for you. Now with the second example, this is subtraction, and there's multiple subtractions, so you want to do your first keep, change, change. 7 plus negative 5, which is 2. And then you've got 2 minus a negative 2. Keep, change, change again. And you've got 2 plus 2 is 4, and the answer would be a positive 4. So make sure you are thinking these through and writing down the steps instead of trying to do too much in your head and make a silly mistake. And now we're on lesson 3-4, multiplying integers, and the rule for multiplying and dividing integers is the same, and it's spun. Same sign positive, unlike signs negative. Alright, some examples here. A negative 9 times a negative 9, two negatives in this case make a positive answer. Even if you are multiplying more than just two numbers at a time, you still need to follow the same spun rules. When you have a product of three negatives, your answer will always be negative. Think back to the worksheet we went over in class. Even when you're dealing with exponents, like the last example, negative 4 to the third power, you're saying negative 4 times itself 3 times. And again, you've got a product of three negative numbers, your answer is negative. Now, if it were negative 4 squared, you'd have negative 4 times negative 4, your answer would be positive 16. So a trick here, if the exponent's even, you should have a positive answer. If the exponent's odd, you've always got a leftover negative, and your answer will be negative. Alright, in lesson 3-5, dividing integers, you're going to use your spun rule again. Here are a few quick examples. These are really pretty easy. The only thing I want to remind you of is how they can write division, where it also looks like a fraction. And that fraction bar is telling you to divide. So in the example, negative 15 divided by 3, your answer is negative 5, because unlike signs, negative answer. However, negative 14 divided by negative 2, the two negatives give you a positive answer, 7. Alright, some of the trickier word problems, and these are kind of mixed up between the lessons 3-1 through 3-5. And some of these you will see something pretty similar on your test. These practice problems came from different homework problems, not necessarily that you were assigned, but they were homework problems directly from your book. So Julie has $20, then pays $5 for a slice of pizza. Write an expression, not just the answer, then find out how much money is left. So she has $20, that would represent a positive. Then she spends money, that would be negative 5. So 20 plus a negative 5, the answer would be 15. She has $15 left. Alright, the next example, a scuba diver descends 10 feet, then 8 feet, and then 11 feet. What's the total feet that the diver descended? Alright, so you could think about this like the absolute value, because you just want the total. You don't want to say the final position. Okay, so you're going to add all of those numbers, and that would be a total of 39 feet that he descended. Okay, You might actually need to say that you're at negative 39 feet because you have descended, you are below sea level. All right, another example that can be tricky is when you're dealing with elevations and finding the difference. Difference means you're going to subtract. This was actually a problem found in the book as well. A mountain climber ascends 30 feet. Ascends means going up. Then descends 15 feet, so obviously the opposite, going down. What is his final position? And so you need to have a positive or negative sign to mark this, because you need to say he is at a positive level or at a negative level. Might even help you to draw a number line and map it out. But you start at 30 feet, which is plus, ascending. When you descend, you're going down, so that would be a negative 15. And then you would look, different signs you need to subtract. The one with the greater absolute value is positive, so the final position would be a positive 15 feet. All right, and our last word problem actually comes from a problem we worked in class or went over as homework in class. It's on page 219 of your textbook and actually has parts A, B, C, and D. So if you feel like you need more practice with this, look in your book to page 219. It's question number 13. And there's a chart where you have to actually look up the information. I just took the key information and wrote it in the math problem above. Okay, so the highest point in Alabama is 2,407 feet. The lowest point in Louisiana is 8 feet below sea level. What's the difference between the highest in Alabama and the lowest in Louisiana? I'm going to pause to answer my phone now. Well, that was fun. Okay. Husband's always interrupting my work. My goodness. All right, so the setup. Take a look here. You're starting out at 2,407 feet and below sea level, 8 feet below sea level in Louisiana. Below sea level is representing a negative 8, so you have to remember that. It didn't say negative 8, but it does say below sea level. Okay? You're finding the difference, which means you're subtracting. So you have to set this up correctly or you're going to get the wrong answer. And this is the key. This is the tricky part. So you've got 2,407 minus negative 8. Now you're going to do your keep, change, change. And you've got 2,407 plus, now the negative 8 becomes a positive 8. Remember, you're finding the difference in total height, okay, between the highest high and the lowest low. The difference total is 2,415 feet, okay? So notice that is an answer where you would have to include your measurement units, which is feet, and the total difference would be 2,415 feet. I would suggest you practice some of those on page 219. And train your brain so that you can pass the math test like a boss. Thanks. Good night.